This video shows how the motor and battery currents are related to the speed and acceleration of a light electric vehicle. The bike I'm riding has a hub motor, a 14S 5P battery, and a little Fokker controller. I've set the motor current limit to 90 amps and the battery current limit to 60 amps. I'm using the Vestool app to log data from a full throttle run starting at a dead stop and reaching a top speed of about 30 miles per hour. The controller is in current control mode, so at full throttle the controller tries to maintain the 90 amps of motor current. This run is on flat ground and I'm at full throttle for the entire run. We load the data into a Python Jupyter notebook, create a time axis in seconds, and create a column of data for the motor RPM from the eRPM. Each of the following graphs will be from a single run of data with a pinned throttle. The first graph is the RPM, which is proportional to the vehicle speed. The slope of this curve tells us how fast we are getting faster, or the acceleration. You can see the acceleration is fairly constant between 2 and 5 seconds. After that, the acceleration slows, and eventually the vehicle reaches top speed and the acceleration goes to 0. The second graph shows the RPM and motor current together. During that constant acceleration between 2 and 5 seconds, the motor current is at its maximum. As the motor current drops after the 5-second mark, so does the slope of the RPM and the acceleration. At full speed, the motor current is only at about 25 amps, about a quarter of its peak value. The third graph shows both the motor current and the battery current and gives us a clue why the motor current started dropping. Between 2 and 5 seconds, the battery current is increasing while the motor current is constant. At the 5-second mark, the battery current reaches its peak and the motor current begins to fall. At full speed, the battery current has settled down to 20 amps, about a third of its peak value. The wind resistance increases at higher speeds, so it's probably counterintuitive that the currents are decreasing after a certain speed. If you're familiar with torque speed curves, you can create a similar graph by plotting the motor RPM on the x-axis and the motor current on the y-axis. Since the motor current and torque are proportional, this curve has the same shape as a torque speed curve. We see that up to about 250 RPM, the motor can produce full torque, but the torque reduces at higher RPM. Here are a few takeaway messages. Increasing the maximum motor current will lead to a higher torque and acceleration. Increasing the maximum battery current will allow the vehicle to maintain full torque at higher RPM. Increasing the maximum currents beyond a modest level won't affect the top speed of the vehicle.